Okay, so far in 9.4, let's summarize where we've been. If I want to talk about displacement, displacement is the same thing as net area, which is the same thing as net change. Formula-wise, if I wanted to come up with something for the net area or net change, I want you to always think that that would be S at B minus S at A, or the integral from A to B of V of t dt. Okay, same thing. Look at number 6, important fact to note. This, the integral from A to B of the absolute value of V of t, that's not the same thing as the absolute value of the entire integral. So if you think about what I have, this part on the left is asking for total distance. This part here on the right is just basically displacement without direction. Okay, it's just going to give you a positive value each time, but it's still displacement. This is actually going to find the distance. So that's important. When it says displacement, I want you to think the integral from A to B of V of t dt, which is equal to S at B minus S at A. Same thing we wrote up above. Okay, if it says total distance traveled, it's the sum of the absolute value of all those displacements. But now, the easier way to say that is just the integral from A to B of the absolute value of V of t dt. I'm going to take all those areas underneath the curve and just add them up regardless of sign, because that's the distance that I will have traveled. Now, as it plays out on the calculator, that's still the same thing. So I'm not really sure where I put this in the notes, other than the fact that displacement, you do not need the absolute value sign. So no absolute value. And then total, make sure you put in the absolute value brackets. And again, you're going to find that under math. So if I'm looking for those brackets, go from math to number, which is ABS, and that'll get you the absolute value brackets that you need. So don't forget to put those in. Old operating system, it's going to say ABS. New operating system, you're going to have these really wonderful math print absolute value brackets. You'll love it. Okay? So math and then number, oops, and one absolute value, ABS. Okay? So look at number 9. If an object moves along a horizontal line, so that at any time t, the velocity of the object is. And they say it's calculator, so without further ado, I'm going to go to my calculator and substitute in x squared minus 7x plus 10 into my y1. And obviously it's a parabola. And even a little more obvious is if I were to factor this, this is just t minus 2, t minus 5. So I'm not even going to calculate the zeros. When it comes up, I know for a fact that the zeros are at 2 and 5. I'm not assuming anything. Otherwise, I might have to calculate the zeros if I wasn't sure. Okay, so A wants to know if t is greater than or equal to 0, so on a positive time interval, when is the object moving to the right? Well, the object is moving to the right whenever v of t is greater than or equal to 0. So that object is moving to the right from 0 to 2, and again from 5 to infinity. And that's in terms of seconds, when it's moving to the right. And we'll put a little justification there. V is greater than or equal to 0 for your notes purposes. B, if t is greater than or equal to 0, when does the object change directions? Well, that's when v is equal to 0 and changes signs. That's going to be at t equals 2 and t equals 5. See, if the position of the object at t equals 1 is 3, so they're giving me s at 1 equals 3. What is the position of the object at 3 seconds. Well, here's our initial value, ending value idea. We want s at 3 is equal to s at 1 plus the integral from 1 to 3 of v of t dt. S at 1 is equal to 3, but the integral from 1 to 3 I don't know. Now, if this were a non-calculator question, I'm going to have to find the antiderivative. But I'm not going to waste that time or spend that time finding it when I can quickly do it in my calculator. So we're just going to do a math 9 on my function for x values from 1 to 3. And we get a wonderful 2/3. So 9/3 plus 2/3 is 11/3 feet. What is the object's displacement from 1 to 3? Well, again, that's s at 3 minus s at 1, but I'm not working with s, and this is a calculator problem, so I'm just going to say that's the integral from 1 to 3 of v of t dt, which we just found to be 2/3 feet to the right. Wait, right? Yep, horizontal line, sorry. Horizontal line. Okay, it wants total distance that the object traveled from 1 to 3, so my total distance will be the integral from 1 to 3 of the absolute value of v of t dt. So I'm going to do the exact same thing I did before. Only I'm going to put in absolute value brackets, and I'm just going to stick them in around y1. So I'm going to go in and just do a little insert, math, number, absolute value. Don't forget to close my parenthesis around that y1. Okay, so I'm finding the signed area under the absolute value, so in this case I'll just come up with area underneath that from 1 to 3, and that's equal to 3. So now if you just look at the graph so you can give some sense to it, what we're saying is the distance from 1 to 3 gives you a total of 3, but the net change we said was only 2/3. There is something on your calculator that kind of shows you and can fill that in. Notice we've always been using math 9. I'm going to show this to you, but I don't want you to use it on a regular basis. If you go to second calc, you'll notice down here number 6 and 7, dy dx should look a little familiar, as the integral from f of x dx is also. Go ahead and hit second calculate and go to that number 7, and it's going to pop you up onto your graph. And it's going to ask for the lower limit and the upper limit. Well, the lower limit for us was 1, and the upper limit was 3. And it actually does shade in that area and gives you the net change. I forget exactly what it is, but there's a difference between this program on the calculators on the second calculate side as there is in the math 9 side. Would you please just always use the math 9? You can look at this to give you an idea of what's going on, but do me a favor and always do a math 9 double check and make sure you get the same exact values. Okay? But I did want to show that to you just so that you could put some visual sense to it. Okay, so we just found the net difference would be 2/3 because this value up here would be positive, this here would be negative. But now if you look at the sizes, this piece is obviously bigger, and it's bigger in fact by 2/3. Okay? So finally, F just wants to know, when is the particle furthest to the left? Well, isn't that when position is at a minimum? So I'm furthest to the left, so its position would be at a minimum. Well, look at your graph, and on here the position is at a minimum wherever v of t changes from a negative to a positive, which is going to be at t equals 5 seconds. And if they wanted to know what that position was, then we would just have to find, we'd have to have an initial value, which we did. They gave us the initial value at 1 second, so I could find s at 5 by saying s at 1 plus the integral from 1 to 5 of v of t, and actually tell you what that minimum position was. It didn't ask it this time, but of course it could. And why? The justification on why it's a minimum? Because, one, it's an open interval, so I'm going to look for wherever my graph, my derivative graph, changes from a negative to a positive, and it's the location of an only relative minimum, therefore it has to be the absolute. Okay? And if you just wanted to play around with it just to make sure, if I looked at that value, let's go ahead and figure it out. If my lower limit was 0, my upper limit was 5, then I get 4.166, so 4 and a 6. And that would be my minimum value starting at 0. Okay, but of course I didn't have the initial condition on there, but it would still have to be the minimum.